Welcome to Pre-Calculus Notes for Essential Skill D1, Right Triangle Trigonometry. In this first video, we'll be reviewing some geometry concepts and adding a couple of new ones. Let's start with SOHCAHTOA. Take a look at this first problem and give it a try. The first thing we need to do is find the length of that third side of the triangle. If you know your common Pythagorean triples, this is easy. It's an 8, 15, 17 triangle. If you don't know them, it would be worth your while to pause the video and write all these down. You're going to see these come up again and again throughout this trimester and the next. Now that we have the third side, we can find sine, cosine, and tangent using SOHCAHTOA. It's important to remember that if we're taking the sine of angle B, its opposite and adjacent sides are relative to angle B. The opposite side is across the triangle, so this is the opposite. This is the adjacent. Hypotenuse is not relative, it's always the hypotenuse. Now we use SOHCAHTOA to complete these ratios. It's important to remember that SOHCAHTOA only works for right triangles. There are three trig functions that you may not have seen before: cosecant, secant, and cotangent. These are the reciprocals of the three primary trig functions. You'll see these abbreviated as CSC of x, and this is the reciprocal of sine of x. Secant is SEC of x. This is function notation. 1 over cosine of x. Cotangent is abbreviated as COT of x, and it's 1 over the tangent. Take a moment to try example 1. Be sure to rationalize any radical values. Once again, the first thing we need to do is solve for the third side of the triangle. This is not a Pythagorean triple, but you might recognize these side ratios as those of a 30, 60, 90 triangle. If you didn't, and you went through the Pythagorean theorem, you should have gotten 5 root 3. If you recognized the side ratios of 30, 60, 90, good for you. That's when the hypotenuse is twice as big as the short side. Now to the trig functions. This is our opposite. This is our adjacent. So 5 root 3 over 10, which simplifies. Cosine of A is adjacent over hypotenuse, 5 over 10, which simplifies. Tangent is opposite over adjacent, 5 root 3 over 5, which again simplifies. For cosecant, secant, and tangent, we'll take the reciprocal and then rationalize. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Next, we have a vocabulary review: angles of elevation and depression. Take a moment, look at the diagrams, see if you remember how to do this. The angle of elevation in the first scenario is the student's elevated line of sight, the angle formed from the normal line of sight and the elevated line of sight. The key to locating an angle of elevation is that we always must form the angle with a horizontal line. In the case of the flagpole, the angle of elevation of the sun is formed with a horizontal line. That horizontal line is going to be the ground. So now we look at the last ray of sunshine that just reaches the tip of the shadow. The angle of elevation is formed with the ground and that line. Finally, we look at the angle of depression. The angle of depression also includes a horizontal line. A lot of people try to identify this as an angle of depression. It is not. It doesn't include a horizontal line. We are depressing our line of sight from the plane, and so our original line of sight is here. The angle of depression is formed by the old line of sight and the new line of sight toward the target. That's the angle of depression. Angle of elevation and angle of depression are very common to find in applications problems, and they can even earn you a bonus point for complexity in your project. So it's important to know how to identify them. Next, we look at degrees, minutes, and seconds. These are fractions of angles. If you've ever seen an angle or a measurement of latitude or longitude in this form, those are degrees, minutes, and seconds. Here's how we define them. If we're given an angle in DMS form, we can change to decimal by using these facts. This would be 29 plus 15 minutes, so that's 15 over 60, plus 20 seconds, so that's 20 over 3600. Going to the calculator, to approximate an answer, remember you can press Control Enter. On the TI Inspire, there's an easier way. The pi key is located down just to the left of the letter pad, and that gives us symbols that will include a degree sign and a minute sign. If you press the minute sign twice, you get seconds. Try this out and see if you get the answers listed. I'll step through and show the keystrokes in a moment. Here's how to do it. If you get the wrong answer, your calculator may be in radian mode. Take a look in the top right. We're in radian mode and not degrees. Let's fix that. Press Dock, go to Settings and Status, and look at Document Settings. The second setting is Angle. You can either click or tab to it. Press to the right. We choose Degree. We tab down and say Make Default. We will be using degrees this entire chapter. Now, press Enter to repeat the last command, and we get a fraction. Press Control Enter to approximate, and there's the answer we were looking for. For the next example, we were finding the value of cosine of 23 degrees and change. So remember that cosine is a trig function. Notice this is where you can find cosecant, secant, and cotangent in the same order that I presented. Notice that they correspond with the order of sine, cosine, and tangent. They are the reciprocals of sine, cosine, and tangent respectively. But I digress. We're finding the cosine of 23 degrees and change. And there's the answer we were looking for. Finally, the TI Inspire has a conversion operator that will let us convert a decimal form angle into DMS form. Here's how to find it. The book is the catalog, but the second function has lots of symbols. That key is located just to the right of the 9. So we will control book, and you'll see lots of symbols. If you don't see the conversion operator triangle up here, you may not be at the top. Scroll up till you get to the top. That's what it looks like. I'm going to press Escape. It'll remember that I found this symbol before. First, I need to type in the angle. 3.27. Now I go find the operator. Remembered. And I type the letters DMS. And there's our answer. The last thing I want to do in this video is to review solving triangles with SOHCAHTOA and a calculator. These are all things that you've done in geometry before, and so why don't you pause this and try all 3 of them. Here's my solution. There are 2 things that I'm going to insist on. First, use the degree symbol. It's very important. We will be working in radians starting in Unit 5, and so it's important just to distinguish between the 2. Second, I'm starting with the trig function itself. Your first statement should be a trig function. Here's where you can take a bit of a shortcut. We're going to multiply both sides by x, and then we're going to divide both sides by cosine of 58 degrees. We'll end up with this. You can do this all in one step, and it's very easy if you think of it as letting the cosine expression switch places with the x. It is algebraically valid. The one thing I want to introduce is that we can use the reciprocal functions to take this exact form answer and make it simpler. The reciprocal of cosine is secant, so this is 7.8 times the secant of 58 degrees. And that is our exact form answer. We can type that into the calculator as is. If you're in degree mode, you don't need the degree sign. And that's our answer. We're simply dealing with an abstract situation, so we don't have units that we need to add. Next, we have a plane descending to an airport with an angle of depression. First, we need a sketch. Here's the right triangle I like to use. The angle of depression is not part of the triangle. However, the horizontal ground and the horizontal line of sight are parallel, meaning that these are alternate interior angles. We can copy that angle measure down here. Notice also our unknown is the straight line distance from the plane to the airport. Straight line distance is from the plane directly to the runway. That affects the trig function that we're going to use. We'll need to use sine. This is our exact form answer. Notice we use cosecant, which is the reciprocal of sine, in order to keep the answer from having fractions. Now we can put it into the calculator. So here's one answer. 186,000 feet is not a very relatable number, however, and so it's important in an application problem to have relatable numbers as your answer. So we'll convert to miles. Remember that there are 5,280 feet to a mile. Remember that on the Inspire, if you just press an operation button, it will assume you mean take the answer and perform that operation on the answer. And there's a much more relatable number, a little over 35 miles. We're told to round to the nearest tenth, so that'll be 35.4 miles. Finally, we have a review of inverse functions with SOHCAHTOA. First, a sketch. The angle of elevation of the sun is the small angle formed with the horizontal ground. We'll call it theta. It's a very common variable to use for angles. Once again, we start with a trig function. When we use an inverse function, we're trying to find the original input to the tangent function. Remember, inverse functions reverse the outputs and inputs. So inverse tangent of the output gives us the original input. Notice that we have the same -1 notation that we did for inverse functions. Remember that this is not an exponent. It's just part of the inverse notation. To avoid this, you may have also seen this written as arctangent. It is the same thing. Regardless, this is a perfectly good exact form answer, and so we will approximate by plugging it into the calculator. The inverse tangents are on the bottom row. And there's our answer, a little over 34 degrees. By default, you should probably round things to the nearest thousandth, unless it says otherwise. That's a good way to ensure reasonable accuracy. At this point, if you want to stop and work some practice problems, this is a good time to work the first couple of pages of the practice set.